Okay, we have to start the chapter atoms and molecules. What's mean by atom? Atom is an indivisible particle. It is the smallest particle. We can say that it is the smallest particle in nature. But the researches are going on beyond the level of atoms. There are a lot of subatomic particles, but here the smallest particle is considered as atoms. The researches are still going on about the study of the smallest particles, Higgs boson, lepton, fermion, bosons. There are a lot of subatomic particles, but we are now studying about the level of atoms and molecules. Okay, so atoms means an indivisible particle, or we can say that it is the smallest particle. The ancient Indian and Greek philosophers were also think about the atoms and molecules, but they unknown about the unseen nature of a matter. Okay, it is a matter, but what is the smallest particle in this substance? They wondered about it. In the 18th century, the researchers developed about elements and compounds. In the 18th century, the scientists know about the elements and compounds. But then, Antoine Lavoisier was the person who established two important laws of chemical combination. It was the first explanation about the nature of atoms or the smallest particles. Then, after this, there were a lot of studies are done, and still now the studies were progress. What are the laws of Antoine Lavoisier? The first law is law of conservation of mass. Law of conservation of mass. It states that mass can neither be created nor be destroyed in a chemical reaction. Okay. The second law states that the second law is law of constant proportion. Law of constant proportion. It states that in a chemical substance, the elements are always present in a definite proportion. Okay, in a definite proportion by mass. For example, H2O. H2O. These elements, hydrogen and oxygen, were present in a definite proportion. So let us understand these two laws by taking examples. Okay, first one, conservation of mass. Conservation of mass means mass neither be created nor be destroyed. So in this case, we take sodium sulfate and barium chloride and combine it. It starts reaction and it forms BaSO4 and NaCl. This is the reaction. If you take 1.53 gram of sodium sulfate and 1.22 gram of barium chloride, then the sum, what is the sum? 2.75. Okay, 2.75 is the sum of these two masses. Then the results should be a total of 2.75 gram. There will be no change in this reaction. It implies that mass can neither be created nor be destroyed by a chemical reaction or something else. Okay, so this is the importance of conservation of mass. Then what is next law? Constant proportion. Constant proportion by mass. Let us take an example, H2O. Let us take this example. The proportion of this mass by element is a constant. That means hydrogen's atomic mass is 1, that we will study in this chapter. So 1 into 2. There are 2 hydrogen atoms. So total weight, total mass is 2 gram. And oxygen's atomic mass is 16 gram. So what is the ratio, what is the proportion in between this hydrogen and oxygen by mass? It is 2 is to 16. Okay, 2 is to 16. That means 1 is to 8. 1 is to 8 is the ratio or proportion of H2O. So you can take any water molecule, any water, but the ratio of the mass of the hydrogen and oxygen will be 1 is to 8 in every word. That is constant proportion. If you take another example, NH3 ammonia, NH3 ammonia. The atomic mass of nitrogen is 14 and hydrogen is 1. There are 3 hydrogen atoms, so 14 is to 3. 14 is to 3 is the constant proportion of ammonia. Then after this, Dalton proposed some laws. We have to discuss it. Then Dalton explains some postulates. These postulates helps to understand the conservation of mass and law of constant proportion by Lavoisier, and provide an explanation for the law of conservation of mass and law of definite proportion by Lavoisier. Okay, what are the postulates of Dalton's theory? First one, all matter is made of very tiny particles called atoms. All elements are formed by atoms. Atoms are indivisible particles which cannot be created or nor be destroyed in a chemical reaction. Okay, it is the second. It confirms the law of conservation of mass. Then atoms of a given element are identical in mass. Atoms of a given element are identical in mass and chemical properties. In a given element, H2, hydrogen, in a given atoms of a given element are identical. This hydrogen molecule, or these hydrogen molecules, H2 means hydrogen molecules, is made with 2 hydrogen. So in an element, the all atoms are identical in chemical properties and also in mass. Then atoms of different element have different masses and chemical properties. Atoms of different element, hydrogen and oxygen. This atom and this atom is different. Okay. Then atoms combine in the ratio of small whole numbers to form compounds. Hydrogen and oxygen combine in the ratio of 1 is to 8 in a mass ratio. Okay, in a mass ratio. So atoms combine in the ratio small whole numbers to form compounds. It is whole number 1 is to 8. 1.1 it is not allowed. So whole numbers 1 is to 8. It confirms the law of definite proportion. Then relative number and kinds of atoms are constant in a given compound. In a given compound, the relative number H2O, it is H2O. The relative number is 2 is to 1. The relative number, how many numbers of atoms of hydrogen is present in H2O? Is 2, and 2 hydrogen atoms combined with 1 oxygen to form water. Okay, so Dalton's theory explains the whole thing in a simple way. Okay, then what is an atom? We discussed that atom is an indivisible particle. Atoms are very small. The radius of an atom can be calculated in nanometers. 1 nanometer is equal to 10 raised to minus 9 meter. That means 1 by 10 raised to 9 1 by 10 raised to 9 meter. That is very very small. Is equal to 1 by meter. We can divide by 9 zeros. how much it is? It's a huge number, but 1 by this is very, very small. Okay, that is 1 nanometer. So 1 nanometer is very, very small. It is the average size of an atom. Okay, then a scientist, John Dalton, represent the elements by symbols. Okay, who was the scientist? Who was the first scientist which uses symbols for elements to represent? This John Dalton, and his symbols, it is for hydrogen, phosphorus, copper, gold, carbon. It is on a slight black representation. There is only a slight coloring, shading. Carbon, sulfur, lead, platinum, oxygen, iron, silver, mercury. It is not much important, but it is the symbol represented by John Dalton. Then after Dalton's theory, the science is grown up. It forms a standard naming group. It is IUPAC. The full form of IUPAC is International Union of Pure and Applied Chemistry. This union makes this union provide names for new element and also for other nomenclature. Okay, so how IUPAC, International Union of Pure and Applied Chemistry, provide symbols for elements. There is standard way. There is a standard way to the nomenclature of elements and also compounds. Commonly, IUPAC provides symbols by taking the first one or two letters of the element name in English. Maybe it is used in Latin, German, or Greek. Okay, the word may not be English. The first letter of a symbol is always written in capital letter, and the second letter is always be in small letter. For example, hydrogen. For hydrogen, we take only UPSC takes only the first letter. It should be in capital. Then aluminium, it takes first two letters. One is in capital, then small. Cobalt, one is in capital, then small. Then another example, chlorine, Cl, zinc, Zn. It is another way. The pronunciation letter, chlor. So second letter is L, zinc. Second pronunciation letter is N. So obviously takes this N for zinc and chlorine. Then another from Latin or Greek, iron. Iron, it is not IR, it is Fe, because ferrum is the word that is derived from Fe. Okay, it is the word ferrum. Then sodium, Na, it is from the word natrium. Then potassium, it is from K, calcium. This K from calcium. So IUPAC takes a standard way to the nomenclature. Okay, then we have to study an important topic in this chapter. That is atomic mass unit. Atomic mass. We can say that it is atomic mass unit, AMU. The symbol of atomic mass unit is small letter AMU. The Dalton's theory provides a way to measure the mass of an atom, because his theory says about the nature of the chemical bonding and the definite proportion. All compounds combine in a definite proportion. Means we have to measure the mass of that elements, and the ratio of that masses will be a constant, will be a definite proportion, that Dalton says. So the scientist wants to measure the mass of that atoms. How it is possible? There is only standard unit kilogram. We can measure the weight of the mass of this object by using thrust. The thrust comparing it with a kilogram, and it may be 200 gram. In such a way, we can calculate the mass of this object because it is a big object when it compared with atoms. But we cannot measure the mass of these atoms by using these instruments. The scientists want to make a new quantity, a new measurement way to find the mass of the atoms. And in 1961, the scientists make a new reference, carbon 12 isotope. They take carbon 12 atom, carbon 12 isotope atom as a reference. To measure this, to measure the mass of this object, we compare with kilogram. But here the mass of this object, this mass of this carbon 12 isotope. We can compare these things with a watermelon system. It's a watermelon, and cut these objects, cut this watermelon as 12 pieces. As 12 pieces. 1, 2, 3, 4. So this is 12 pieces of watermelon. So I take 1 pieces from here. Is one watermelon, 12 pieces. It is the 1 by 12. This total is considered as 1 watermelon. Okay, this total 12 pieces jointly give 1 watermelon. So this piece is the 1 by 12th of watermelon. So the weight of this, the mass of this object is the 1 by 12th of the watermelon. In such a way, the scientist explained the mass of other objects by comparing the isotope, carbon 12 isotope. That means 1 by 12th of the mass of the carbon atom. This 1 by 12th of one carbon atom is said as 1 AMU. The mass of 1 by 12th of carbon 12th isotope is called 1 atomic mass unit. What is 1 atomic mass unit? 1 atomic mass unit is a mass unit equal to exactly 1/12 of the mass of one carbon isotope, carbon 12 isotope. The relative atomic masses of all elements have been found with respect to an element of carbon 12. This carbon 12 isotope is the reference. This atomic mass unit is universally accepted. Okay, so atomic mass unit is the universally accepted measurements in atomic level. It helps to measure the mass of the other elements by comparing this carbon 12 atom. That means 1 atomic mass unit. So the mass of a hydrogen atom is found at 1 AMU. Mass of hydrogen atom is 1 AMU. That means 1 by 12th of carbon 12 isotope. Okay. The mass of one hydrogen atom is equal to the 1 by 12th of the mass of carbon 12 isotope. In such a way, we define atomic mass unit. Then you have to study the standard masses of some atoms. Okay, masses of atoms compared to 1 by 12th of the mass of carbon 12 atom. That means in atomic mass unit, what are the masses of elements in atomic mass unit? AMU, 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 all things. Okay, the mass of hydrogen is 1 AMU, mass of carbon is 12 AMU, nitrogen is 14, oxygen 16, sodium 23, magnesium 24, sulfur 32, chlorine 35, 35.5, calcium 40. This is an important thing and you have to study it. So you should study these things. I will ask it in the next class. It is an important one.